What we are doing is potential. Okay, I'm just going to hold it. This isn't working. We are doing potential to kinetic energy, and you are comparing two ways to make a light bulb light. What are the two ways you're comparing?
One with just a battery, a light bulb, and wires, and another one with
an electromagnet, batteries, and wires.
Okay, so first can you show us, because that's a blob over there and we didn't have it set up that way. Oh yes, I'm sorry. Sorry, Mr. Crosby's class, we'll get you over there.
Right, we're getting a tour of your classroom this way.
There we go. So where is just the regular?
right here.
Okay, and then Jeremy, you need to take that out because we need to talk about what an electromagnet is. So that's just a regular circuit, and a regular circuit has a battery, a light bulb, and wires, and that's it. And it lights. Can you get down closer so they can see the light? See how it's lit? There we go, it's lit. Now we're moving to an electromagnet circuit, and how do we do that?
First, we make a circuit, and then we would take a piece of metal. We're going to try 3 different types of metal. We're going to try a paper clip, a nail, and some tin foil. And then we wrap the wire around the nail or the tin foil or the paper clip.
And that wrapping makes a magnet?
Yes.
Okay.
When the electricity attaches with the wire, it becomes an electromagnet.
Okay, I just want to stop you for a minute and ask the people in the Google Doc, does that match their form?
Foils?
Does it match their form?
There's 2 forms, electromagnetic energy and coils.
Right, the number of coils. Isn't that all you were doing was changing the number of coils? You just changed the variable on your experiment. Your original experiment was to change the number of coils. And what you're looking to change now is the what you're coiling.
We're going to do both.
No, you can't change your experiment now.
Coils used.
Right, it's the number of coils. So we're using the nail. Sorry, we're getting this together. We're using the nail and we're coiling a number of times to see if we can get it bright. That's what you're doing. Can you go turn this light off?
Students, just make sure that what they're writing in Cover It Live is appropriate for what we're discussing.
Yeah, stick to the topic.
You see that?
Okay.
It's all about science, not everything else.
So what's the first number of coils you're going to try?
We're going to try 5 coils.
Okay, so 5 coils.
1, 2, 3, 4, 4.
Okay, 5 coils. How many of you think this is going to be, with just 5 coils, how many of you think sticking an electromagnet on this circuit will make it brighter than the bulb? Than just the bulb? How many of you think it won't do anything? How many of you have no clue? So that's the question we want to ask in the Cover It Live. Is what we're doing is adding an electromagnet to the circuit, and we want to know if that's going to be brighter than our original circuit. That's what we're trying to see. So we did 5 coils, which doesn't make a really strong magnet, but it should do something. And let's see what happens. Is the bulb, oh, I can't get that close.
Wait. Actually, it's even lighter than snap. It really.
So Alexandra, down a little so people can see. It looks like it's about the same.
Oh wow. Well,
It looks about the same. So, did it affect anything?
No.
So was there was it brighter with 5 coils?
No.
So what are we going to try now?
10.
10 coils. Google Doc people, 10 coils. How many of you think 10 coils will make a difference? How many of you think, nope, 10 coils will not make a difference? Okay, that's the question in the Cover It Live. Will 10 coils make a difference?
Don't cover it live. Will 10 coils make a difference?
So that was 10.
Right?
And here we go. And Alexandra, you gotta step out of the way. And doesn't look much brighter.
It looks darker.
Yeah.
Looks darker.
It looks less lit.
Looks dimmer.
It does, actually.
Okay, what are we gonna try next? So that one was dimmer. What are we trying next? 15.
Wait, hold on, you're going a
Right?
little
So
back.
That's why there are 4 of you in the dock.
Be brighter or dimmer.
We're trying 15 coils.
Say what you think, you cover it live.
Now, Mr. Crosby, while they're counting this,
Wrapping a wire around the nail and just type into cover it live what you think is going to happen. Is it going to get brighter or is it going to get dimmer? Yeah.
Mr. Crosby, I just want to point out that when we have our science day next Friday, the day I told you about,
Right?
that we were going to do, this might be another experiment we try, because I'm already, and maybe you can think of this too and put it in the Cover It Live, I'm already thinking of reasons why that light bulb would have gotten dimmer.
Ah,
I think
okay.
so. I know why too.
Because remember when we did the when we did the sound experiment, and we said maybe we didn't get the results we were expecting because of other reasons?
With Jackie and Julia
Right.
from Mrs. DiOrio's class, please return to your classrooms.
So it could be that this also has other variables we're not accounting for.
Okay. So you look at my class, just to make sure everybody really understands what they're doing. Because they've got a nail in there, pretend this is wire instead of string.
If you can get really close to that so they can see.
The nail, that's coils, coils, it up, right, coils? First time they wrapped it around 5 times.
Okay, we're up to
Then they
15. Is
wrapped it around 5 more times.
that what we're doing now, 15?
Yeah.
What happened? What happened?
Is it obvious now?
Right? Now they're wrapping it around 5 more times.
I
So
think some
now
of these
in the
children
will
have to
say,
leave.
write it, correct, 15 times. What do you think is going to happen?
Okay, how many of you think 15 is going to be brighter?
Right,
Did the 10 throw you off? So now we're thinking, forget it. It's not going to be brighter. Okay, let's see.
For me.
Okay, we need to bring our bulb back over here.
And it.
And it is...
A lot dimmer.
dimmer.
I know why.
Dimmer.
I think I know why.
Okay, why do you think it's dimmer?
Tracy, I need a roof shift relief.
Okay. Why do you think it's dimmer? Billy, why do you think?
Because it's taking
Wait, let me point this over here. Why?
it's taking more energy.
Oh, so the electromagnet circuit is pulling energy from the bulb? That could be. Arib, what do you think?
losing sound of
Oh, you're losing our sound? That's our sound, so we might have unplugged a bit. Let me just make sure we're still plugged in.
Howie.
You okay now? Okay. Sorry. So, Arib, what do you think?
Because it won't work because it was wrapped around too many times and then it won't like work because it was wrapped around.
Okay, I'm going to tell you a little bit about electromagnets. Actually, the electromagnet group can tell us. What makes the electromagnet circuit stronger?
The electrical force when it's wrapped around the nail.
So the more times it's wrapped around,
The stronger the force is.
So the nail becomes a magnet?
Yeah.
so the more times it's wrapped around, the stronger the force should be. And yet, in our experiment, it's not.
Well,
Why?
maybe it is. Maybe the nail is becoming a stronger magnet, and that's taking power away.
And that's exactly what Billy said, that it was taking away the power from the light bulb. Should we just try 20 and see real quick?
Just out of interest, and you don't have to do this, but I'm wondering if you have another nail or something made out of metal, if while you do that and you put another piece of metal, does it really act like a magnet?
Oh, to see if we can pick it up. Okay. No, he wants to pick up the paper clip.
As the light gets dimmer.
See, I think you all have great ideas. Much better ideas than me. Kind of like in math today. And you had better ideas than me. It's not my day today, what can I tell you? I was thinking it was the bulb. That the bulb was going out.
Oh, and I thought so too. We were sitting there thinking, and it really wasn't the case.
Well, it could be, but I kind of like Billy's idea. But Reeves' idea goes against electromagnetism.
Nail, the nail turns into a magnet. So you can pick stuff up made out of metal. Just like
So
a
how
magnet.
many times are you wrapping it now?
So
I'm
they're
not sure. I'm
thinking
just
what's
wrapping it
going on
around
is
as
when they
many
put
as I
more
can to
coils
pick up
around
the
it,
nail.
the nail
Oh, but we
becomes
need to know how many
stronger
times you're
magnet.
wrapping.
And that's taking power away from getting to the light bulb so they don't get so bright. Does that make sense?
20 times so far.
20 times, we want 25.
How many coils are we up to now?
We're gonna do 25 coils.
25 coils this time. So, if it keeps doing what it's been doing, what should happen this time? It should get even dimmer.
So
okay?
right, so it should be dimmer or not work at all. What an interesting experiment this is. I totally didn't get this.
Wouldn't have thought it.
This time we're actually going to try using the paper clip to pick it up, which should be interesting.
Okay, can you say that a little louder so they can hear you?
We're going to try to pick up the paper clip with the, while it's in the circuit, we're going to try to pick it up with the nail.
Okay, so the bulbs.
We switched bulbs and that one is now lighter.
Okay.
So it must be a problem with the
bulb, but
why
let's
that-
see if we can pick up the paper clip.
Put the paper clip down.
Someone turn
Yeah, you need to slide over. And we are not.
Wait,
We're picking it up a tiny bit.
Wait, I'm gonna hold this here. There's definitely a magnetic force, but not strong enough to hold the paper clip.
You can tell there's magnetic force there, but it's not enough to hold the weight of the paper.
Right,
correct?
and when the bulbs were changed, the light was brighter. So there was something with the bulb. I think that this is an experiment that when we have our science day, we need to just try this a bunch of times and see what we can do with it. But thank you so much. You know, one of the things that you need to understand about science is that we learn from mistakes. Most science experiments fail
Failure is always
because then what can the scientists do?
learn how to fix it.
Make another experiment that might work. So we have a lot of things we talked about here. We talked about maybe we're making the magnet stronger and that's why the bulb is dimming. So I would love to try that, to just keep coiling and see if the bulb gets dimmer and dimmer and dimmer. We also talked about maybe it was the bulb. So that might be something to try different bulbs.
I wonder if that works with dimmers.
Oh, a dimmer switch.
I wonder if that has something to do with the dimmer switch in the house.
Maybe. So thank you very much, you three. You can